Hello, everyone. It's 6 o'clock. I'm going to go ahead and wait a bit for people to join. Hi. Got one of my first viewers. I'm eating dinner. And, yeah, it's been a long day, but I'm ready to get started when you are. I guess instead of waiting, I could start. So, I did have a student reach out struggling with substitution and elimination. And substitution and elimination are crucial pieces of algebra because they actually are seen every day. I like to think of substitution as making a sandwich. So if I have, let me rotate this. If I have a sandwich, here's my bread. And I have another slice. Not very cute, but whatever. And I have ham, and I have, I don't know, onion, and I have, and let's just make this cheese, blue cheese, whatever. Substitution just means you have to take what you're given and just put it on or insert it. So again, take what you're given and insert it. Take what you're given and insert it. Do the math, and then put this piece on top and solve, basically, if my pen would turn on. So that probably wasn't the greatest explanation, but I think that it will make sense in a moment. So let me just look for a problem that the student had. So one of the problems was, let's see here. Today is the 6th. Oops. Okay, so let's see here. So this is one of the problems I can see that the student had. It was x equals, that's a little too high. You guys can't see that. X equals y minus 7. And then the other one was, the other equation was negative y minus 2x equals, I think that's 8. I can't really read it very well, but these are our two. Can't see that top one. Let me make it. X equals. Okay. And I think that to make this a bit easier, actually, I'm going to use a different color for that x, so you can kind of see what's going on. So x equals y minus 7. Okay. So with substitution, the way that you can tell that you can use substitution in a problem is when you can see that your x or your y value in either equation is on its own. And when we say it's on its own, it means that there's no math going on around it. There's no number, there's no division, there's no addition. It's literally just the x or just the y on one side of the equal sign. And so in this case, I know that I can use substitution because of that. X here, that is on its own or isolated. Substitution, like I said, is like a sandwich. You take your ham, put it on, take your cheese, put it on, whatever that it is. And in this case, we only have one ham, I guess. And the ham that we have is this x. So if x is my ham and this equation down here, the negative y minus 2x equals 8 is my bread, I need to take my ham and put it in or on my bread. So you're probably wondering, how do I do that? All you do is you find in your equation, in your other equation, not the first one, not x equals y minus 7, look in your second equation here in the blue or the dark blue and find your ham, or where your ham should go. Your ham needs to go where the x is, because technically x is our ham, right? So I'm going to take that x, I'm going to replace it here. And the main thing you need to realize that you're not just replacing the x or substituting the x, you're substituting the entire x. And the entire x in this equation is y minus 7. So negative y, you keep that, minus 2, and we've substituted our x. We've replaced it with the entire x, which is y minus 7. And that still equals 8. We're not changing the second equation at all. So I have substituted x for what it is, the entire thing, into my new equation. That is substitution. Now I'm going to do some math. So negative y, you're going to FOIL. You're going to take your negative 2, FOIL it over to the y, FOIL it over to the negative 7. So you're going to get negative 2 times y is going to be negative 2y. And then negative 2 times negative 7 is going to be positive 14. And this is still going to equal 8. So now I'm going to combine like terms. So I have negative y and negative 2y. Those look the same. And that is going to be negative y minus 2y is just negative y plus negative 2y, which is just negative 3y. We still have our plus 14, and it still equals 8. I'm going to jump all the way back up here so we have some room. Uh-oh. Can't see that. There we go. Okay. Move my head. So now I'm going to move some stuff around. I want to get my y by itself. So I'm going to subtract 14. Whenever you want to get a variable by itself, you have to undo. So I'm going to undo this 14 by subtracting it. Whatever you do on one side of the equal sign, you have to do on the other. So 8 minus 14 is negative 6. This goes away because 14 plus negative 14 minus 14 is 0. And I'm going to bring my negative 3y back down. We still have 3y equals negative 6. Divide both sides by negative 3 because you want to undo what is happening to the y. And the y is being multiplied by negative 3. So we got to divide by negative 3. And whatever we do on one side, we do on the other side. That's why it's dividing by negative 3 on the other side. And so then our final answer, negative 3 divided by negative 3 is just y. And then negative 6 divided by negative 3 is actually positive 2. So we found that our y value is positive 2. But in substitution, this is not just your answer. When they're asking you to substitute, they're trying to figure out what is the value of y, but what is also the value of x. So doing all this substitution, all this math, there is a goal, and the goal is to find what the value of x and y are. We found that y is equal to 2. So the only way to find the value of x is to again substitute this 2 back into the equation. So I'm going to go ahead and create a new sheet here, but I'm going to keep the x equals y minus 7 consistent because we're still going to use that. But I'm going to make sure that we know that the math that we just did on the other side is still relevant because y is still equal to 2. So in this case, we're doing another substitution. We are going to substitute our y, which we can call our ham, I guess. And that y is going to substitute in for the y sitting where that x is because we want to find out what x is. We got to know it. So if I do that, you'll see that x equals, instead of writing y, we'll write 2 because we replaced it or substituted it, minus 7. And if I do that math, I'll get x equals negative 5. So I have my x and I have my y. The answer to a substitution question is always an ordered pair. An ordered pair is x, comma, y. So our answer for this particular problem would be negative 5, comma, 2. I hope that makes a bit of sense for that particular problem. We can try another one just for practice. So again, in this case, we're going to use substitution. and then we'll do another example of elimination in a moment. So one of the problems I see here on the sheet, maybe I should choose a harder one. No, let's make it easy. So we have 2y equals negative 3x. And then, I keep writing above the page, which I don't like. So let me make it bigger. There we go. I think that's good. That should be good. And then I'll move this a little lower because y'all don't really need to see me that much. In fact, I can make this even a little smaller. Okay, I think that's good. So now let us do our second equation, and our second equation is going to be y equals negative 2x plus 2. So these are our two equations, and again, our goal is to find x and y. The reason why we know that we can use substitution in this case is because our variable y in one of the equations is isolated or on its own. There's no math occurring here. It's just y on one side of the equal sign. It doesn't matter if it was on the left or on the right. As long as our variable or a letter is on its own, you can use substitution. So now, what are we going to do? We're going to substitute this y into our top equation. So we're going to have 2, and in this case, our y is not just y, it's actually negative 2x plus 2. So the whole thing, everything that y equals, is going to go in for y, and it's negative 2x plus 2. And we're going to set that equal to negative 3x. That does not change. So now we can do some math. 2 times negative 2, we're going to FOIL, and 2 times positive 2. So 2 times negative 2x should give us negative 4x, and 2 times positive 2 should just give us positive 4. We're going to set that equal to negative 3x. Nothing occurred over here, so I'm going to keep bringing it down. Guys, in algebra, take your time. There is no hurry. There is no rush. Bring it down slowly. Every transaction or everything that you do it in one go and then go to the next thing. That's the best way you can do it. Take it in steps. So in this case, I see that there is some stuff going on here. You might have been told in algebra that everything needs to be on one side. That is the case here. You can move everything you can move your x's to one side, left or right. It does not matter as long as x's and your numbers are isolated on their own. So here on this left, I have negative 4x plus 4, and on the right, I have negative 3x. And when I say left and right, I'm talking about the equal sign being that barrier. So I'm gonna actually go ahead and just move everything to the left. When I mean everything, I mean my x's. I'm gonna move my x's to the left. So to do that, I'm going to move this negative 3x, and to move things, you have to undo them. And to undo a negative 3x, you have to add the 3x. You will not multiply it, you will not divide it, you wanna actually move the entire thing. So I'm gonna add 3x on both sides, and you're gonna see here that I'm gonna add it to right underneath my other x, and there's a reason for that. When you are moving terms around the equal sign, you have to pay attention to like terms. So anything that has an x with it goes together. And then anything that's just a number or doesn't look the same, it just stands alone. So on this side, negative 3x plus 3x is going to be 0. So we can put 0. That's fine. We're going to bring down our 4 because we didn't do much with it. And then negative 4x plus 3x will actually give you negative 1x or just negative x, depending on how you want to write it. It's no big deal. So now we're getting closer and closer to having your x's on one side and your numbers on another. But in this problem, we still have that plus 4. So I want to move that plus 4. I want my x's to be alone. I want my numbers to be alone. So I'm going to subtract 4 on both sides. And it's the same thing again. You're going to bring down your negative 1x or negative x. It doesn't matter how you write it. And then plus 4 minus 4 will cancel out, which is just 0. You don't have to write that one. And then 0 minus 4 is negative 4. Some of y'all may say, hey, this is right. That's enough. I found my x. But the truth is, negative x equaling negative 4 is not your final answer. Whenever you're looking for variables, you do not want negatives around them. You want the positive version. So for negative x equaling negative 4 as the answer, it would not be correct. I want to find the positive version. So x needs to be positive. How do I do that? X right now is negative, and it actually has a 1 beside it, and I can put that back in for you. So a negative 1 is being multiplied by x to equal negative 4. And again, if you want to get x by itself positively, you need to undo what is happening to it. So here, I'm not going to add it, because if I add it, it's just going to remove the entire negative 1x to the other side, and then we're back at square one. We just want to get rid of that negative 1 so we can have x by itself. So to get rid of it, since it's being multiplied, we're going to divide by negative 1. And whenever you do that to one side, don't forget you have to do it to the other side. And when I say side, remember it's the equal sign. So negative 1 divided by negative 1 will cancel out, and now your x is positive. And negative 4 divided by negative 1, now your 4 is positive as well. So I found my x value, x equals positive 4. And in the last example, we learned that we had to substitute x back in, or the letter back in, to find the other letter. So we have to find y. And in that one, I used the top equation. But I want you to know that it doesn't really matter. Either you use this one or this one. It doesn't really matter which one that you use. So use the bottom equation, plug your 4 into that x, and you'll still get the same answer. And I can show you that here if you'd like. So let's go off to the next page. 2y equals negative 3x. And we know that our x was equal to 4. We know with substitution, we take our ham and we put it into our sandwich, and then we solve. So 2y equals negative 3. Our x in this case is all of the x, which is 4. And then 2y equals negative 12, because negative 3 times 4 is negative 12. And then we're going to divide both sides by 2. Again, undoing what is happening to y to get it by itself. So y will equal negative 6. So again, when you write your substitution answer, it has to be xy, or an ordered pair, which is 4, negative 6. This is your answer. Your final answer, at least. So let's try, that was the top equation. And I wanted to show you the other equation, if we were to put the 4 in there, that you should get the same answer. So it's going to be y equals negative 2x plus 2. And our x was 4. So again, I'm going to take my ham, which is x. I'm going to replace or substitute that x in my equation to find y. And it'll be negative 2 times 4 plus 2. So now y equals negative 2 times 4, which is negative 8. We're going to add our 2 back in, because we didn't do much with it. And negative 8 plus 2 is negative 6. So I have my y again, I have my x, has to be an ordered pair, x comma y. So our final answer is 4, -6. Does that match what we just did? Does that match this one? Yes. 4, -6. So I'm letting you know here in this particular example is that when you're substituting back in to find your other letter after you found your first one, you can use either equation. You should get the same answer. If you get something off, it might just be your math might be wrong. That's it for substitution. Not sure if anyone has joined, and that's okay. But let's work on elimination. Elimination is a bit more tricky. Okay. Okay, so let me choose one that's not too bad to start. They all look pretty. They all got a lot going on. So let me choose, well, I guess we can just go for that one. I think that will be fine. So x equals, actually, x plus, 2y equals 5. And then 3x plus 2y equals 17. Okay, so these are our two equations, and this is for elimination. So with elimination, it is pretty different from substitution, at least in the beginning, but you'll see kind of where substitution kind of comes back in to find your other letter. So the way to tell that you might need to use elimination instead of substitution is when your x or your y is not isolated. So as you can see in both these equations, x and y is on the same side. They are not alone. So you can't just throw stuff back in. I mean, you could if you move some of these equations around, but normally when you see it like this, two equations, x is not isolated, y is not isolated, you're most likely going to need to do elimination. The key to elimination is that you want to eliminate a variable. So it's either you eliminate your x's or you eliminate your y's. Try not to eliminate any of your numbers. So your numbers that stand alone, in this case 5 and 17, should not be eliminated. Please do not try that. We're going to either eliminate x or our y's. And when you do that, you want to take a look at your equations as one whole package. So the way to think about it is these two equations, they go together, meaning whatever I do, they need to be added, subtracted, whatever that it is, they go together. So the main thing after you add your line is to look at your equations and say to yourself, if I look at my x values and I want to eliminate these, what do I need to do for them to be to basically equal 0? So when you eliminate, you're going to be adding down your equations. So this has to be an addition problem. This will have to be an addition problem down. And then this will have to be an addition problem. You're adding them down. So if I look at this first red one, I could use it, but honestly, it doesn't matter which one you choose. You can eliminate your x's or your y's. In my opinion, you always want to eliminate the number or the variable where the two numbers match but aren't opposite. So in this case, if I look at my y's, so if I erase all of this and I go to my y's, I can see that my y both of them have 2's on them. Those look like they can be eliminated quite easily if and only if one of them were negative. Don't forget, elimination means when I add them down, it should equal 0. But in this case, if I add them down, it's equaling 4. That is, if only one of them were negative, it would equal 0. So with elimination, you're going to have to do some changes to these equations to do that elimination or to get those variables to equal 0. So let's do it. I want one of these two y's to be negative. And you might just want to go ahead and throw in a negative like so, but that's not possible. You can't just throw in a negative. It's not possible in math. So if you want to make a number negative, you have to make the whole thing negative. So if I was to rewrite this with a negative, we're going to take that negative out here. We're going to make this x negative. We're going to make this 2 negative, and we're also going to make this 5 negative. So when I rewrite it, it'll be negative x minus 2y equals negative 5. We did not add a negative to the bottom, so please do not mess with it. Just 3x plus 2y, put it back in, and we're going to add our line underneath because we're going to add down, right? Immediately, your thought should be, finally, these two can be eliminated because I know if I add negative 2 to positive 2, that will equal 0. So I can eliminate these. That's what elimination is all about. You want to find your variable where the numbers match, but one of them is negative, the other is positive. And sometimes you have to, add a negative in by multiplying it all the way through. You might have to multiply by an actual number, and we'll get to that example in a moment. But now that I have my y values eliminated, I'm still working on the problem. We're not done. So I'm going to take negative x, and I'm going to add that to my 3x. And that will give me positive 2x. I'm going to erase the 0 because we know that 0 is 0. We don't need to pay attention to it. And then negative 5 plus 17 should be 12. We're making headway here. We want x by itself because the goal with elimination is similar to substitution. We're trying to find out what the x value is. We're trying to find out what the y value is. So divide both sides by 2, and x will equal 6. So now that we found that x is 6, we are now going to figure out what y is. So remember I told you that when you are doing elimination, there is a piece of substitution to it. And this is where the substitution comes back in. So similarly in substitution, you took your x value, you plugged it right back into any of your equations that you started with. And we're going to do the same thing here. So if I go to my next one here, I'm going to use that top one, x plus 2y equals 5. Always use your original. It's always easier. Use your original equation. Use either one. I'm just using x plus 2y equals 5 because I think it's easier. So we found that x was equal to 6. So we're going to take our ham and substitute it for the x. And we're going to rewrite our problem with this substitution. So it's going to be, instead of writing x, we're going to write 6 because x is 6. We're going to add 2y and we're going to subtract. It's going to be equal to 5, sorry. We're going to undo everything that is happening to this y so we can get it by itself. So we have a 6 and we have a 2, but let's take it slow. Let's start with the 6. We're going to subtract 6 on both sides of the equal sign. 6 minus 6 will give you 0. We're going to bring that 2y down. It's still positive. And it's going to be equal to 5 minus 6, which is -1. We're going to divide both sides by 2. 2y divided by 2 will just give you y. So y is equal to -1/2. So our answer for this particular problem, again, it has to be an ordered pair, 6, -1/2. Not too bad, right? So let's try another example. Let me look at the sheet. Yeah, that one, it's pretty tricky. So I'm gonna go ahead and try a bit of a difficult one here. And just follow along. So the problem I have is I have negative, let me give myself room this time, so I don't think I had enough room. So -7 x plus 3y is going to equal 12. So there's my first equation. And then I have my second equation, which is 2x minus 8y, which is going to equal -32. That's the problem I have. Okay. So this one's a bit trickier, but still the same concept. We're going to use elimination. The reason why we know that is because we have our x's and y's on the same side of our equation. And yeah, that's the best way to tell. So again, the goal is when you add down, you want either your x's or you want your y's to equal 0, right? Right now, -7 plus 2 is not 0. And 3 plus -8 is also not 0. But we can make them equal 0 as long as what? As long as both of them are the same number, but one has to be negative. In this case, it doesn't matter if you want to make your x's the same number where one is negative, or if you want to make your y's the same number and one is negative. We can try both ways and you'll see you'll get the same answer. But in this case, I'm going to go ahead and make my x's the same number where one is negative. So you want to think of a number that can be multiplied by these two to make the same number. So the best way to think about it, the easiest way to do this is to think about these two as you're gonna use them to multiply to equal this number. So 7 and 2 can go into what number? The smallest number. So it can't be 7 because only 7 can go into 7 one time. 2 cannot go into 7. So you're gonna look for a number where 7 and 2 can go into them perfectly. And the only number that I can think of right now is 24. I mean, 20, not 24, 14. So 7 and 2 can go into 14. They may not be the same multiple, but they both will equal 14. And one just needs to be negative. So let's do that. To do that, you're going to go ahead and multiply both the top and the bottom equation because you're trying to match those x's. So on the top, if I want 7 to be 14, I'm going to multiply it by 2. And on the bottom, if I want 2 to now be 14, I'm going to multiply it by 7. So now I should have negative 14x plus 6y, and this is just me foiling, negative 2 times negative 7, 2 times 3, and 2 times 12 will give me 24. That's my new equation. I'm going to do the same thing with the bottom equation. 7 times 2, that will give me 14x. Do you see how now they match? 7 times negative 8 will give me negative 56. And 7 times 32. What is 7 times 32? If you don't know, of course, use your calculator, but you could always just do it the old school way. Don't forget your negative. 2 times 7 is 14. 7 times 3 is 21. Well, and then 21 plus 1 is 22. But since you had a negative there, it has to be a negative 224. So this is my new equation. So now we have these two numbers. One is positive, the other is negative, which is great. And they match. That means this can immediately be eliminated. That's 0. My x's are gone. That's what I want. So now I'm going to add down. So don't forget, these need to be added down. That's how negative 14 plus 14 is 0. 6 plus negative 56 will give you a positive 50y. And 24 plus negative 224 will give you a positive 200. Is that positive actually? Let me think about that. 6 plus or 6 minus, this will be negative 50 actually. 6 minus 56, yeah. And then 24 minus 224 will give you negative 200. Let me make sure I do that right. There we go. Negative 200. These are big numbers. So now divide both sides by negative 50 to get y alone. And y, these cancel. Negative 50 divided by negative 50 is 1. So y is equal to negative 200 divided by negative 50, which is positive 4. So we found our y. And don't forget, we need to find our x. So I'm going to go to a fresh page, and I'm going to use any equation, any of my previous equations. I can either use this one or this one, and use it before it was changed. So try not to use the equation that you multiplied a number by. Try not to use these two. Use your initial equation. So I'm going to use 2x minus 8y equals negative 32. Oh, negative. And we found when we did our elimination that y was equal to a positive 4. So now all I'm going to do, let me just check and see if anyone joined. Yeah, somebody did. Hey, thanks for joining. If you have any questions, please feel free to add it to the chat. I'm just about wrapping up here with this one. So now we're going to take our ham, which is y in this case, and I'm going to plug it right back in to my y in the problem or the equation. So now instead of y, I'm going to write 4. So 2x minus 8 times 4 equals negative 32. And then 2x, negative 8 times 4 is going to be negative 32. And this is also negative 32 on the end. Now we're going to get rid of the 32 on this side by adding it on both sides. These cross out, and I'm left with my 2x. This comes down. And 32, negative 32 plus 32 is going to be 0. I'm going to divide both sides by 2. And 0 divided by 2 means that x is equal to 0. So I have x is 0 and y is 5. So my answer to this is 0, 4. And I didn't mean to say y is 5, y is 4, sorry. You must write it as an ordered pair. So this would be a correct answer on your test, quiz, homework, whatever that it is. Okay. Someone is here. Did you have any questions? About 15 minutes, ask away. Don't be shy. You can ask in the chat. Or if you shared something with me, I can check my email. I think if there are no questions, I'm not seeing one yet. I can do another one, another example. Okay, so where was that? There it was. Okay. Sent. So now we're going to do one more example here for elimination, and then I think we'll be at time. And let me find one that's not as tricky. They're all kind of tricky. Let's try this one. So 11x minus 6y equals 3. Then our second equation is 5x minus 8y equals 25. Or that's negative 25, sorry. So make that negative prettier. So with this one for elimination, the reason why I know that I can do elimination is because my x and my y is on the same side of the equation. So substitution immediately off the bat is not going to happen here. So the first thing I want to do is take a look at both my x and my y's. So in my x's, I have 11x and 5x. And in my y's, I have negative 6y and negative 8y. Again, it doesn't matter which ones you select to eliminate, as long as they are the same number and one of them is negative. So I'm going to go ahead and I'm going to decide to eliminate my y's this time. It doesn't matter whichever one you do. Just know that you do have to add downwards. So in this particular problem, if I'm focusing on my y's, we have negative 6 and we have negative 8. If I add those down, those will equal negative 14y. This is not going to work. I want to eliminate these. When I add down, they should equal 0. So I'm going to go ahead and change them so that they are the same number, but one is negative. That's the only way that I can eliminate them. So I'm going to go ahead and multiply the top and the bottom. I know I have to do that because 6 and 8 are not the same number, but I want them to be the same. So for the top one, we want to think now, what number can go in, what is the smallest number that 6 and 8 can go into? So we can start with 6. Obviously, 6 cannot work because only 6 can go into 6 one time. 8 cannot go into 6. Let's try 12. 6 can go into 12 2 times, but 8 cannot go into 12. So let's just keep going. Let's try 16. 16, 8 can go into 16 twice, but 6 cannot go into 16 at all. So you just keep thinking about the different numbers. And then the one that I can think of right off the bat is 24. 6 can go into 24 4 times, and 8 can go into 24 3 times. So I'm going to make sure that 6 and 8 are now 24. The only way to do that is to multiply this top one by what number? Anyone in the chat know? If I want negative 6 to now be 24, positive or negative, what number do I need to multiply negative 6 by? Yeah, that's great, Erica. It's going to be positive 4. So I'm going to take my positive 4 for the top, and then the bottom, I want that 8 to also change to a 24. So what number does 8 need to be multiplied by to equal 24? Yep, that's right, Erica. It'll be positive 3. So I'm going to give myself more room on the end here. And when I do that, I'm going to multiply the bottom by positive 3. So let's do that. 4 times 11x on the top will now give us 44x. And then 4 times negative 6y will give us negative 24y. And then don't forget, you have to multiply the 4 by the end number too. So this is going to equal positive 12. Great, we got the top down. Now let's do the bottom equation. 3 times 5x will give us 15x. And 3 times negative 8y will give us negative 24y. And 3 times negative 25 will give us negative 75. But there's a catch here. I still don't have two numbers that are the same, but one has to be negative and the other has to be positive. I see 24 in the middle is really close. But both of them are negative. If I add both of these down, this will not be eliminated. It will not equal 0. So how do I make one of these numbers positive? What do I need to multiply the entire top by? -1, yes. Erica, you're doing great. I feel like you know this stuff. So this is great. So I'm gonna multiply the top by a -1. Sorry, it's a little messy, but when I do that, you'll see that all of these, make it a little bit neater. So all of these, I'm gonna do it from underneath because it's a bit tight up top, are gonna change. So my new equations are going to be -1 times 44x is going to be -44x. -1 times -24 is going to be +24y. And -1 times 12 is going to be -12. The bottom doesn't change. We did not do anything to it. It's still 15x, -24y, and -75. So now we can add these down because 24 minus 20 or plus -24 are y's. These will eliminate themselves, which is the goal here. So it becomes 0. -44 plus 15 is going to be -31x. Oh wait, that's not right. That looks like maybe -29. X. And then -12 plus -75 will give us -87, right? So I'm going to erase this 0 in the middle because we don't need it. So in the middle here, we have actually just an equal sign. -29, x equals -87. To get x by itself, we're going to divide both sides by -29. -29 divided by -29 is 1, and so x will equal -87 divided by -29, which should be 3. +3, because a negative divided by a negative is a positive. So I found that my x equals 3, but we're not done. I know elimination can be a lot sometimes. I totally get it, but we're almost done. So I'm going to move on to a new sheet since we're all out of room here. And what I'm going to do is I'm going to take one of my original equations, the one that I started off with before I started multiplying and subtracting and whatever I was doing. We're going to take the original one, and the original one I'm going to take is that first one, 11x minus 6y equals 3. So this is one of my first equations I started off with, and I know that my x is equal to a +3. I found that out by doing elimination in that first page. And so now I'm just going to do substitution here. So don't forget, elimination always somehow leads back to substitution because you have to put in your x to find your other variable, which is y. So I'm going to take my ham, which is x. I'm going to put it into my sandwich here, which is the x in the equation. And so then I'm going to replace that x with what x actually is. And x is 3. So 3 replaces x or substitutes x, 6y, and that's going to equal 3. 11 times 3 is 33, minus 6y is 3 as well. And then you're going to subtract both sides by 33. So minus 33, minus 33. And negative 6y is now equal to 3 minus 33 will give you negative 30. You failed all your math classes, Erica? Oh my goodness. Well, I am so glad you're here. It's never too late to go back to school. I'm glad this is helpful. So we're going to divide both sides by negative 6. And so now we found that our y is equal to a positive 5. So our final answer for this problem, we have our x here, we have our y down there, and it's going to be 3, 5. This is a perfect answer on your homework, test, quiz, whatever problem you are working with. Well, it is 7 o'clock, and this was great. I got through every problem as much as I could. Thank you, everyone that joined. Thank you, everyone that viewed. I hope you have an amazing day. Please don't forget, we are here every Tuesday and every Thursday, every single week, unless, of course, I say so. So please be sure to join. These are free office hours for Algebra 1, pre-algebra, Algebra 2, algebraic reasoning, and even college algebra. So if you're struggling with any of those, bring your questions. You can shoot me an email ahead of time so we can go over any problems that you might have. So thank you, everyone. Go have some dinner and have a great rest of your day. Bye, Erica. See you.